Okay, please listen. You can also undo names to write balanced formulas. Example, dichlorine heptoxide is Cl2 O7. Well, a moment ago we were taking the formulas and writing names, so we're just reversing the process. That's what it means, okay? So if you'll take note here, di means 2, hept means 7, and you're right, the chlorine is Cl, oxide is the oxygen. Okay? Okay. Okay, so write the formulas for nitrogen trifluoride and disulfur dibromide. Nitrogen trifluoride and disulfur dibromide. Dibromide. Good.
Is it going to get harder?
You know it usually does.
Is it going to get harder today?
Probably not. Hmm? We're going to have some homework.
We have homework every day.
How about that?
The long balloons like the sausage?
Where do you find that?
We need long balloons.
I've never seen that.
Bromide is born. Bromide. Long balloons and red What's bromide?
Solid colors,
How many of the same color?
but different colors. Okay? Solid colors, but different colors. Solid blue, solid red, solid yellow, solid orange, solid purple. I'd kind of stay away from black, but it's okay if you want to bring them. Well, in this case, black is not beautiful. It's just hard to write on them. I mean, you can bring a white marker if you want to. It's just hard to write on black balloons. Well, you could use whiteout. That's true, but how much? That's a lot. That's hard. Yeah, it's a little extra work, right? Okay. And you know how much people complain about having to do extra work right here. So. All right. They do make white markers. I mean, if you want to go out and spend extra money and buy a white marker just to bring back black balloons, that's okay with me. You want to do that? That's not good. All right. All right. So what we're going to be doing in the next couple of days is learning how these covalent formulas go together. When we're learning about ionic formulas, we learned about exchanging electrons, where electrons from metals were given up and electrons went to and were gained by nonmetals. Yes? Yeah, we're going to check it in a second. All right. With covalent compounds, it's a bit trickier. The naming's probably easier, but formulas for covalent compounds are a little bit harder to figure out. Okay? And that's where Lewis dot formulas are really, really helpful. Okay? We used the example of carbon dioxide earlier. I'm going to give you a quick preview. I'm going to go back and tell you what the answers to these are, and then I'm going to give you the homework. Okay? So with carbon and oxygen, you already know that you have 2 oxygens and 1 carbon. Now you start out with the Lewis dot formulas the same way that we started out with them when we're doing ionic formulas. Carbon has how many electron dots around it? You need your periodic table to figure out how many dots you put around carbon. 4 of them. There are 4 valence electrons in carbon. 4 outermost energy level electrons around carbon. How many electrons do you put around oxygen?
4.
Don't guess wildly. Look it up on your periodic table and figure it out. 6.
How do you know that?
How do you know that? Well, because oxygen's highest energy level is 2, and in that second primary energy level there are 6 electrons. That's the valence electrons. 1, 2, N2S, 1, 2, 3, 4, N2P. 2 plus 4 is 6. Okay? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now the way that we're going to work this out is, again, with ionic compounds, you either got rid of all the electron dots or you worked it out so that you had 8 electron dots around a monoatomic ion. In this case, we're going to work it out so every element has 8 electrons if that's possible. Every element will have 8 electrons if that's possible. So with covalent bonding, we're going to share electrons. Okay? With covalent bonding, we're going to share electrons. So carbon could share this electron with oxygen. And carbon can share this electron with oxygen. Okay? But that gives the oxygen only 7 electrons and the carbon only 5. So we can share a couple of more. Share those 2 electrons and share these 2 electrons. Now both carbon and oxygen have 8 electrons. The carbon is sharing 2 electrons with 1 oxygen and 2 electrons with the other. And the way we write that then, once we've shown how they share, the 1, 2, 3, 4 shared electrons are going to be put between the carbon and the oxygen. And the unshared pairs out here, those on the outside that aren't shared with anything, those are just simply left on the outside. And this is a Lewis dot formula for carbon dioxide. What we're showing here is how carbon is going to share 4 electrons with each of 2 oxygens. So that's what we're going to be working on tomorrow. And the following day, we're going to use those balloons to figure out how we get molecular shapes from that. Okay? Now let's go back to our check yourself problem. If I don't have any prefixes in front of the word nitrogen, then I simply have the symbol for nitrogen. I don't need more than one, I just have it one N. But I have a prefix tri in front of fluoride. The IDE ending was added to it because it's the last thing in this name. So what we want is an element that starts with FLUOR. And that element is fluorine. Fluorine. And so the tri means I have 3 of those, F3. Disulfur dibromide. Well, sulfur is just an element on the periodic table. That should be fairly easy. That's an S. If I have 2 sulfurs indicated by this di prefix, that's an S subscript 2. Bromide, remember we added that IDE on the end. We took off a syllable on the end and put on IDE. So I'm looking for an element that has BROM in its beginning, and that would be bromine. The prefix di means I have 2 of those as well. BR subscript 2. How did you do? Good. I'm going to put it up right now. Yes. Sure.